Welcome back. In last lecture we were talking about the terraces, and I also explained that what are the importance of terraces and why it should be mapped. So, the main concern of mapping the terraces right now, because what we are learning in this course is related to the hazard part also. Okay. And of course, this is one of the most commonly found landscape in the fluvial regime. So, what are the reasons and we can say the causes for the formation of terraces, and what exactly we have? Of course, we have briefly talked about what are these fluvial terraces. They are basically the abundant alluvial floodplains which are been incised by the river, and that resulted into the formation of step like feature which we call the terrace. So, they are this terrace, alluvial terrace or fluvial terrace formed due to incision or cutting into the alluvium or the bedrock. So, usually it has been seen because when the stream is flowing through different areas, of course, it will initially start flowing over the bedrock also, okay, and then deposition of the loose material will result into the accumulation of the sediments, and that can also result into the alluvial terraces. So, in many locations, if I have to take this section here, suppose there is a channel here. So, you have the incised bank over here. So, if you look at the section, then you may come across that there is a bedrock at the base, and then you are having like the alluvium sitting at the top. So, this is quite common actually. So, incision occurs as a result of change in the base level. Now, what is the base level? That we have not discussed, but I will just briefly tell you what exactly we are talking about the base level. So, suppose you are having like a stream which is coming from the upland, and then so you can say that this is we have an upland here. So, coming from the stream or coming from the upland and then getting into the plain area. So, this can also be termed as an base level actually. But more in general, what base level we consider is that we have like a stream flowing from the top, its origin, and through its journey finally it gets into and meet the ocean. Okay. So, ocean is been considered as a base level. So, you have an ocean here. So, this is the what we can say the uplands, where is the source, and then finally it is ending up the journey over here in the ocean. So, ocean will be your base level. So, whenever as I also discussed about that, if you are having like, so this is your longitudinal profile, this will be your elevation, and this is your distance. So, I also discussed briefly in the beginning that the channel will always try to keep itself in equilibrium. So, the point is that whenever there is a change in the base level, if it, for example, if it reduces, okay, so the base level decreases because of the sea level fall, then the channel will try to accommodate its profile in such a way, so that matches your base level. That again we can say that it will try to bring itself in equilibrium. So, this is important part. So, this usually we take as in general that this is the base level, but base level could be a local base level also, and that can be seen close to the mountain fronts. So, mostly what we see that there is an like Himalaya is always rising. So, if this keeps going up Himalaya, then this base level is changing. Okay. So, the earlier it was like this, then of course, this remains the same, but then this rises actually. Okay. So, the base level keeps changing here. So, in change in the base level here will also forces the channels, the rivers to incise, okay, mainly. So, this is what we call the change in the base level, and that will result into the incision, or we can say the down cutting. So, this is most commonly observed phenomena in active areas, which we call tectonically active, where local base level will result into the formation of terraces. And these terraces can be, you can say, erosional, or you can have depositional terraces. That means that this will, if I say that erosional, then we can say the degradation, and depositional we say gradation. So, this is commonly observed in tectonically active area, even though this process can be seen in normal conditions also. Okay. So, that we should have an eye, or we should have an experience to differentiate between whether this is tectonically driven incision or this is because of tectonics. Mainly we are talking about the ongoing deformation between the two plates, or any deformation because of the plate tectonic moments. Okay. So, change in the sea level, that what I was explaining here, that if your base level changes because of the change in the sea level, this is mostly seen controlled by climatic fluctuations. So, caused by tectonic uplift or subsidence, that what I was explaining here. This is the reasons, or maybe we can say the causes for the base level change. One is the sea level. So, this one is the sea level, this one we can say this is because of the uplift or the subsidence. Then change in the discharge condition and load discharge relationship. So, I will just remove this part here, so that you can see things clearly. So, this is again related to, as I told, the natural processes can also result into the change in the base level. So, if you are having sudden influx coming of the sediments because of your erosion, that can also result into the change in the base level. So, discharge conditions are changing, where tributaries are pouring more of the sediments into that, or maybe it is related to some other reasons, or increase in precipitation can also result into the discharge conditions. Then classification of terraces, as I explained here. So, this is your, either you can say erosional, or you can say it is there the depositional one. Okay. So, in general, terraces are erosional features, because mostly the terraces, if you initially say that okay, this is your channel, then second phase will be your formation of the terrace. Okay. So, you will see the formation of terraces. So, this is your T0 youngest terrace, and then you can have T1, T2. So, this could be a T1. So, this we are talking about when typical this cross profile of the channel, you will see when we are having like sort of a pair terraces. Okay. So, right now this is what we see, these are if you have typical this type of profile, then you can say that this is your typical paired terraces. So, the erosional terraces, because both are been formed because of the incision, that is why we say that in general they are the erosional features. So, erosional terraces are those cut into the bedrock. Okay. So, this is what I initially talked about, that you have an if at the base of the alluvium you have bedrock here, and if there is an incision in the bedrock and then you are having the alluvium here, then we say this as an erosional terrace. Okay. So, where of course, this alluvium or the alluvial deposits were also deposited by the same channel, and it has incised further within the bedrock also. So, this is your bedrock. So, this type of terraces are been termed as strat terraces. Okay. I will show some example of that. Okay. Depositional terraces are those cut into previously deposited alluvium. So, valley fill deposits. Okay. So, usually the channel will have a tendency to aggrade. So, aggradation will be and again in common process. So, if you are having like the deposition taking place, and then finally the whole channel is filled up with the sediments. So, for example, if you are having the channel here and this channel is getting filled up, so this is what we call aggradation. Okay. And then there is an incision of within the channel. Okay. So, this deposits are incised and you are seeing the formation of terrace here. So, this terrace, this type of terraces are termed as your depositional terrace. I am just putting dt, but if it is incising suppose here you are having the bedrock, and if it is incising bedrock also further down, so that will become your erosional terrace. However, this you will not be able to differentiate when you are mapping this terrace using the satellite photographs or high resolution satellite data, whether it is erosional or depositional, but our aim should be that first to map the terraces. Okay. But just keep this in mind when you are extracting such features while doing the labs. Okay. Now, this is a photograph of on the way to Nainital, and one of the tributary of the major river, and what we see here is that these are all like purple color and grayish color material inclined in like this. Okay. These are the shivaliks, and this is what we call the bedrock. And on top of that, this part where I am putting in very roughly a line here, this is all alluvium. Now, this alluvial deposit, if you closely look at, then it looks something like this. I think, if I am not wrong, I do not have the close up photograph, but anyway, this is all comprised of gravel plus sand and all other materials. So, mainly this is all what we call fluvial deposits. So, below is your bedrock, So, we have just discussed that what type of terraces we can call. So, this is a surface here on which you can see the tree, the vegetation, tall trees. This is termed as Strath terrace. So, scientists also take into consideration that if there is an incision of so many meters, this could be related to your tectonic related base level change. This is another photograph of the same channel, where you can see now clearly what you have as your. So, there is a bedrock here, you can see there is a bedrock, this one, and on top of that you have the alluvial material, and this is the surface here. This is the surface. So, again this is your alluvial material or alluvium, and this is your bedrock. So, this again you can classify this as an strat terrace, or you can say erosional terrace. Similarly, here you can see that these are all, but this one in particular we say this will be a depositional terrace, because we now this also can be classified as a strat terrace, because there is an incision here within the bedrock, and then you are having on the top the alluvium, and this is your bedrock. Lateral migration is, as we have also learned, a very common process in the meandering pattern, and in such cases what you see is that you will get in sort of an but here we do not need to, because we will not be able to see the section on the photographs. So, anyway, this something looks like this actually. If you see the topography, then this portion which is in depositional side, and this is an erosional side. So, you will find that typical section will be something like this actually, okay, and that what we see. So, from the top also you will be able to judge this very clearly on the that this is one side is you are having a cliff. Okay. So, if I am trying to put this in 3D, so this is what you will be able to see how from the top. Okay. So, you have this going on like this, and this will be in slightly flat area, but not very much incised as compared to this one. So, this will be having a very prominent cliff. So, this will be a cliffy bank. I will just change my pointer color. So, this is your cliff, and this side will be in sort of a very low topography. So, this you can make out. Of course, along with this, like you will see the, so this also marks the surface or the terrace, okay. But in typically you will be able to see this when you are looking at the meanders. Okay. So, when you are looking at the meanders, so this side will be your cliffy bank actually, and this side you will have a shallow side like this. Okay. So, this we have already discussed, that if you are having the alluvium and the bedrock, then we mark this as an erosional terrace. So, this is an example of the erosional terrace. This is your the front area of the Himalayan front over here, and the photograph which you are looking at on the top is from this area actually. So, this is the photograph which has been shown here, which shows clearly that you are having the upper Shivaliks. This is again a bedrock, and on the top you are having the young channel fill deposits, that is your alluvium. So, again these are typical of the Strat terrace. So, how it looks in the photo, if you are viewing the 3-dimension view of this area, that we will be talking when we are doing the labs actually. Okay. So, depositional terrace is done, which we have discussed briefly ahead also, that mostly this will not incise the bedrock. Okay. So, no incision in the bedrock. But this you will be able to judge when you are doing the field. So, you have to check the terraces which are been mapped using the satellite data, and then you go into the field and check whether this is an erosional terrace or depositional terrace. Now, landforms associated with the fluvial system, there is a classification which talks about the different stages, that is, if it is youth, mature or old, and what are the erosional landforms associated with the youth stage, that is the young landscape, and matured and old one, and in the fluvial system. So, usually we say that okay, fine, if the valley is young, then it will have, like, it has just started the erosion and all that. So, initially we will have V-shaped valleys, deep gorges, and so on. Okay. And this what we have discussed in the beginning, that how the drainage basin evolves. Okay. And here the depositional landforms are been shown here, that mostly you will come across the alluvial fans. Okay. No flood plains, meanders, no deposition of the alluvial fans will be there. But as you move towards the mature and older, what you see is that, of course, this is matured has been shown for the ocean side also, but usually in the mature and older system you will see the floodplains, natural levels are developed, terraces are developed. So, this is a process which clearly indicates, even which what we have talked about the oxbow lakes, because just this the drainage has formed, so you will not be able to see the formation of oxbow lakes. It needs time to keep, because it will take time to flow through an area. For example, if you are having a meander here, so it is not an overnight process. Okay. It will take time, and then it will develop the oxbow lakes and all that. Okay. So, this is what you can even judge based on the landforms, whether you are seeing the terrain in a mature stage or you are looking at the terrain in the young stage. Okay. So, this part we have discussed, but we will just look at because as I told that morphometric analysis we will be doing. So, we can quickly look at that, what is the importance of the bifurcation ratios and the drainage density in the basin. Okay. Now, this is the photograph from a great run of Kutch. Okay. Where we barely see any vegetation. So, this area is like, it gives a very good example of how the drainage is been evolving in that area. So, this is an area where great runoff Kutch. So, if you carefully look at the drainages where I am putting my pointer, these are the small drainages which are coming, and then we see in the drainage basin evolution. Okay. So, what we were talking, this is on very miniature scale, and one can walk through this regions. Okay. So, these are all like drainage basins we see, smaller ones, and then slowly they are. So, whenever we go after a couple of years, we see that there is some sort of an extension of the drainage because of the ongoing evolution of the drainage basin. Okay. So, this also you can see here, this is evolving like this. Okay. So, then typical of the small smaller order streams joining here and getting into the trunk stream. these are typical of how we see the evolution of the drainage here. Here also you can. So, this what we would like you to understand, and then try to extract this information and give your views, that is your interpretations, okay, towards the landscape evolution. And so, this one is the major one. This is a major stream which is flowing, and smaller streams, that is the tributaries which are joining it. Okay. There is another example which I just to show you that how the landscape evolved, but this is on very quick time scale, because this is not taking time, but this is just to this is an beach in Andaman. So, and there is a slope over here. Okay. So, ocean water comes in. So, this is during the tide, high tide and low tide, okay, and even during the tidal fluctuations you will see that. So, water was coming right up to this and going back. Okay. And what I saw when we were doing the field in this area, that on a very miniature scale the landforms were developing. Okay. So, this is what I found, and whatever we have learned or discussed so far about the different channel patterns. Okay. So, one is your straight, then second is meander, and third is your braided, okay, and in combination of both all. Then we talked about the terraces, then alluvial, fan, then delta. So, these are the landforms which we were talking about. Okay. And of course, connecting to this one, we talked about the point bars, then braid bars. Now, you can see these are all braid bars. Okay. Small braid bars here. And then you have, like, because the water is, this is just a loose sand, and the water is coming and going down, and then we have like over here we see a sort of a meander, and then the formation of terraces here, because there is a migration here on this direction. Okay. There is again a braid bar here on this very small scale. Okay. So, this is a close-up photograph, so that you are able to see. Maybe I am having another photograph I will just show. So, this typical of the process which we see here is been operating on very large scale on the landscape, and that's how the landscape has been shaped up. Okay. So, if you probably, yes, you have the close up of that. So, you see that there is an erosional bank here, there is an erosion bank, and then we have a terraces here. So, there is a terrace 1, there is terrace 2 and terrace 3. So, on the small scale we can see that. Okay. So, as we have learned about the channel pattern, based on the channel pattern also you can talk about the bed load. Okay. So, what type of bed load you will expect if you are having straight channels, you are having meandering channels, and so on. Okay. So, this is a detail which have been given about the different channels. Okay. And what will be the bed load. So, you are having the bed load here, mixed load and suspended load. You will be looking at different, and then we have also discussed about the anastomosing channels, and we were talking about the braided channels also. Okay. So, you can go through this one also. Okay. So, I will stop here, and will come back with the few more slides on this topic, and then move to the morphometric analysis. Thank you so much.